Okay, so another theorem that we have about parallel lines is the transitive property of parallel lines, and that says if two lines are parallel to the same line, then they are parallel to each other. And we can really prove this just using the transitive property. So here, let's say if P is parallel to Q and R is parallel to Q, then P is parallel to R. And that is because P and R are both parallel to the same line Q. Okay, now we're going to go into some proofs of proving that two lines are parallel. So for number one, I'm given that R is parallel to S, and again I can see that with these red arrows here. That means that those two lines are parallel, and I'm also given that angle 1 is congruent to angle 3. So I'm going to go ahead and write my given information first. So I have R is parallel to S, and angle 1 is congruent to angle 3. And I'm trying to prove that P is parallel to Q. Okay, so to prove that P is parallel to Q, I need to use one of those 4 theorems that we learned about in the first video, or the converse. I need to use either the corresponding angles converse, alternate interior, alternate exterior, or consecutive interior converse. So first, looking at just my two lines I'm trying to prove are parallel, P and Q, I need to figure out where am I heading, where I'm going to try and prove. Well, it's only two angles that involve both lines P and Q are going to be these angles 2 and 3, because those touch both. So what type of angles are angles 2 and 3? Well, those are alternate interior angles. So I want to somehow prove that these two angles, 2 and 3, are congruent. So I want to somehow get there. Well, let's see what I can say so far. So I know that these two lines are parallel. So what angles can I say are congruent from that? Well, since those two lines are parallel, I see that that means that angle 1 is congruent to angle 2. And why am I able to say that? Well, I'm able to say that because those are corresponding angles. That would be the corresponding angles theorem. And that again is because R is already parallel to S. Well, now I can see that I can go ahead and jump to that angle 2 is congruent to angle 3. And why am I able to do that? Well, angle 1 is congruent to angle 3. Angle 1 is also congruent to angle 2. So that I can say that angle 2 is therefore congruent to angle 3 by the transitive property. And so now that I have that angle 2 is congruent to angle 3, I then can say that P therefore has to be parallel to Q by the alternate interior angles converse. Okay, let's look at another one. So here I'm given that P is parallel to R. Angle 1 is congruent to angle 3. And I'm trying to prove that L is parallel to M. So first I know that P is parallel to R. So I need to see what statements can I make from those two being congruent to each other. Well, the two angles that are going to involve those two parallel lines cut by a transversal is going to be this transversal M. And so I see I have angles 2 and 3. Well, what type of angles are 2 and 3? I see that those are alternate exterior angles. So I know that those two angles are therefore congruent. So I have angle 2 is congruent to angle 3. And again, that's from the alternate exterior angles theorem. Okay, since angle 1 is congruent to angle 3, angle 2 is also congruent to angle 3, I then can say that angle 1 is congruent to angle 2. That's by the transitive property. So now how come I can say that L is therefore parallel to M? Well, since I have angle 1 is congruent to angle 2, and I have these lines L, M, my transversal would be P. Now what two angles are those? What types of angles are those? Well, I see that they're in that same position. They're both in the top left corner. So they're in that corresponding spot, and since they are congruent, I can say that these two lines are parallel by the corresponding angles converse.